Hello guys, in today's grade 11 mathematics equations and inequalities exam clinic, we are looking at Gauteng Province's mathematics paper 1 of June 2024. So as you can see, this question is a 35 marks question that says we must be done in exactly 35 minutes. So this video shouldn't be more than 35 minutes. However, in that period of time, we will try to explain where we need to explain. All right. So we will do our best to give you the best lesson. Now, let's start. Okay, let's start. Now, checking our question 1 here. This is question 1. Let's see. Let's start. So, 1.1 says determine the value or values of x for which the expression square root of x squared plus 4 all over 9 minus x 1.1.1 has real values. So for this to have real values, the expression under the discriminant, that is the radicand, shouldn't be negative. And again, the denominator shouldn't be 0. So with that being said, we are basically saying the denominator must be greater than 0. So you can see this basically says 9 minus x is greater than 0. So this means our x must be less than 9. But let me show you. Negative x is greater than negative 9. Therefore, x is less than positive 9. Okay? X is less than 9. All right. This is your answer. 1.1.2. Which values of x will this expression be not defined? In other words, which values of x will this expression be undefined? This is when the denominator is 0. Okay, our denominator is 9 minus x. When it is equal to 0. So we can see this is when x equals 9. All right, but let me just write it in this way. I'm just writing it in this way, guys, for those that sometimes get confused when we put x on the right and not on the left. Okay, but otherwise x equals 9. That's our answer. 1.1.3, given x equals 1, is the expression rational or irrational? Validate your answer with an appropriate calculation. So, if x equals 1, they said x equals 1. So this means this will become x squared plus 1, sorry, x squared plus 4 all over 9 minus x, right, will become 5 over, I might say 9 minus x, but rather 9 minus 1. And this becomes 5 over 8, square root of 5 over 8. Now, do you guys know the square root of 5? It somehow you can, square root of 5. 5 is not a perfect square. So is 8 is not a perfect square. So this therefore says the expression is irrational. Okay, the expression is irrational. Why? Because we don't have the square root of 5 and we also don't have the square root of 8 simply as a perfect square, right? So the expression is irrational. Okay, because these square root of 5 is a third and then square root of 8 is also a third. All right, perfect. 1.1.4, determine a value of x where the expression will yield a recurring decimal. I see square root of x squared plus 4 all over 9 minus x. And I know square root of 4 is 2, square root of 9 is 3. So if I can try x equals 0, it will work. Let me show you. 0 squared plus 4 all over 9 minus 0, we will get 4 over 9, its square root. And this is 2 over 3 because square root of 4 is 2, square root of 9 is 3. And this is 0, 0,6666666 and so on. Right? So we are good. Now we are done. Our first 4 marks, we are done. Now let's go to 1.2. 1.2 says, given 2x squared minus 3x minus k equals 0, determine x. So 1.2.1, when k equals 5. So this then becomes 2x squared minus 3x minus 5 equals 0. It seems like this is easy to factorize. So open bracket, 2x minus, leave a space, close. X minus, leave a space, close, equals 0. All right. Now, the constant here is 5. We need product of factors of 5. It is 1 and 5. If we put 5 here, it'll mean 2x times 5. So I'll rather put it here. And this is as factorized. And our answer, x equals 5 over 2 or x equals 1. With that being said, hold on, we are not done. X, the 5 is supposed to be negative and this guy is supposed to be positive, right? So this is as factorizing, therefore x equals negative 1, right? This is why I like putting minus and not a plus at first, because it's easy to make it a plus. Moving on. 1.2.2, when k equals 4, correct to 2 decimal places. This says we will be using quadratic formula. So let's see. Minus 3x, the value of k is 4. So it's going to be minus 4 equals 0. As you can see, a equals 2, b equals negative 3, and c equals negative 4. Right? Moving on. Our quadratic formula is x equals negative b plus minus square root of b squared minus 4ac all over 2a, isn't it? All right. Now, we have the value of b is negative 3. So let's see. The value of a is 2 and the value of c is negative 4. All right, and all this, once again, 2, the value of a is 2. Simplifying, negative times negative 3 will be positive 3, plus minus 4 times 2, or negative 4 times 2 is negative 8. Negative 8 times 4 is positive, or negative 4 times negative 8 is positive 32. Positive 32 plus 9. This must be square root of 40, square root of 40, square root of 41, isn't it? This is square root of 41 all over 4. Guys, please use a calculator when you get to this, okay? Use a calculator. All right. Now, the step I'm writing now, it's not that important, but for those that really need this, when you have an equation like this, it's because it's a plus minus, it says on one part you have a minus, okay, the very same thing. And then on another part, you have a plus. Okay, we have a plus, just like this. Okay, so let's see. 3 minus square root of 41, all these over 4. You get x equals negative 0.85, because they said correct to 2 decimal places. Or here, I'm not changing the sign, the minus becomes a plus. This then becomes 2,35. Just like that, we are done. Okay. All right. So far we have done 9 marks. 9 marks. All right. We are almost there. Slightly delayed, but almost there. 1.3. So for x, when you have 1.3.1, x minus 4 equals negative square root of x minus 2. If you like, you can square everything as is. So basically saying x minus 4 close all square, open bracket, negative square root of x minus square root of 2, square root of x minus 2. No, come on, close all square. You will have x squared minus, okay, let's see, you will have x squared minus 8x plus 16, isn't it? X squared minus 8x plus 16. The negative times the negative is positive. Then you are simply left with x minus 2. Okay. Then, collecting like terms, x squared minus 9x plus, what is this? Let me see. Let me see. So this is a plus. So this will then be plus 18, isn't it? Plus 18 will be equal to 0. Correct. Moving on. This is easy to factorize. We will say open bracket x minus, leave a space, close, open, x minus, leave a space, close, equal 0. We are looking for product of factors of 18. Okay, we are looking for product of factors of 18. They are 1 times 18, 2 times 9, 3 times 6, isn't it? So the constant is positive. Both will take the sign of the middle 10. So the sign of the middle 10 is 9. So let's find their sum. Minus 1 minus 18 minus 19. That's wrong. We don't need that. Minus 2 minus 9. That's minus 11. We don't need that. Minus 3 minus 6. Yes. So this becomes minus 3 minus 6. Okay. This becomes minus 3 minus 6. So x equals 3 or x equals 6. So because you have a Z here or a radical here, you need to confirm which value will be correct and which one will not be correct. Or if both can be correct, go for it. If when you check which one will be, or rather which one its left hand side will be equal to its right hand side. If you, when you check, you find that the first one that you're checking, its left hand side equals the right hand side, you don't have to proceed to find the other one. Okay, you just stop there and say the other one is invalid. So let's test with, let's say, when x equals 6, I'm going to try the left hand side. It'll be 6 minus 4, which will be positive 2. Now the right hand side, it's impossible. So check, negative 6 minus 2. This is 6 minus 2 is 4. So this will be negative 2. So for this one, left hand side is not equal to right hand side. Therefore, x equal 2 is not a root. I mean, x equals positive 6 is not a root. The value of x here is positive 3. Okay, perfect. 1.3.2, let's go. X squared. This is x squared. Oh, before I proceed, guys, remember, this is just a test you do. Okay? No. Where am I? Thank you. This is just a test you do. You don't really need to write it down. Okay? You don't really need to write it down. All right, perfect. So 1.3.2 x squared plus 4 is greater than 3x plus 2. Collecting like terms, x squared minus 3x plus 2 is greater than 0. Factorizing x, open bracket x, minus, give a space, close, open, x minus, give a space, close, is greater than 0. The constant here is positive, so both factors will take the sign of the melted. Product of factors of 2 and 1, isn't it? So this is easy. So critical values. So our critical values here are x equals 1 and x equals positive 2. Because this is a smiling parabola, let's just draw it like this. Right? It's a smiling quadratic. Right? The lowest value is 1, the highest is 2. We say which values of x will this guy be positive? That's above this line. So that is to the left of x equals 1. So we'll say this is when x is less than 1, or to the right of x equals 2, you can see it's above this line. Right? So if you want to understand, this line represents the x-axis. Above the x-axis, y is positive. Below the x-axis, y is negative. Okay, and this is it. This is our answer. Okay, this is our answer. All right, now let's proceed. Okay, let's proceed. As we proceed now, let's see. We are going to 1.4. Okay, 1.4 is still a nice question. So let's see. 2x equals, oops, I think I should just leave some space. Okay, 1.4, 2x equals y plus 2. I'm going to call this equation 1. And then we have another equation that says 2x squared equals 2 minus y squared. This I'm going to call equation 2. We cannot manipulate directly to get our values. So we will have to introduce equation 3. So we will create equation 3 from one of these two equations. The one that is easy to manipulate is equation 1. Therefore, we can say y equals 2x minus 2. This is equation 3, right? From equation 1. Now, for those that struggle with this, then you say substituting equation 3 into the equation that you did not create equation 3 from. Which equation is that? It's equation 2. So on equation 2, wherever you see y, you see 2x minus 2, or you place 2x minus 2. So this says 2x squared equals 2 minus, open brackets, 2x minus 2 close square. Then we have 2x squared equals 2 minus, open bracket. FOIL method of this binomial will be 4x squared minus 8x plus 4. Okay, plus 4. Proceeding, we have 2x squared equals 2 minus 4x squared plus 8x minus 4. Collecting like terms, since the negative 4x squared is negative, let me take it to the left hand side. It will become 6x squared. This guy is positive. It will become negative 8x. 2 minus 4 will become minus 2. Coming to the other side, it will become positive 2 equals 0. Then the highest common factor of these three numbers is 2. So dividing by 2 throughout, or taking 2 as a common factor, whichever you like. Dividing by 2 throughout. This is to basically say 6x squared over 2 minus 8x over 2 plus 2 over 2 equals 0 over 2. So this is not really important. It's just me showing you how to get your answers. All right? All right. Now moving on. This becomes 3x squared minus 4x plus 1 equals 0. Right? You guys can see this, right? Now, this is easy to factorize. So we'll say open bracket 3x minus leave a space close open x minus leave a space close equals 0. Products of factors of 1, this is 1. So it's going to be 1 and 1 because the constant here is positive. The factors will take the sign of the middle term, which is negative. So this is fine, right? So we have x equals 1 over 3 or, or x equals positive 1. So for those that struggle with this, let me just guide you. Substituting these values, right? Substituting these values into equation 3. Remember equation 3 was y equals 2x minus 2. I will confirm. 2x minus 2. Yes, it was 2x minus 2. Cool. So you will say y equals, where there's x, you put 1 over 3 minus 2. Here you're supposed to get 2 over 3 minus 2 is 2 minus 6. So it's supposed to be negative 4 over 3. Please use a calculator. Or y equals 2 open bracket 1 close minus 2. This becomes 0. So this says when x is 1 over 3, y is negative 4 over 3. When x is 1, y is 0. Okay? That's it. 1.5 is my favorite question in this paper. 1.5 and 1.6. So let's see. So 1.5, thank you. So 1.5, for which values of p will negative 2x squared plus 4x minus 3 equals negative p have 2 unequal roots? That's for your 1.5.1. We have negative 2x squared plus 4x minus 3 equals negative p. This is the same as saying negative 2x squared plus 4x minus 3 plus p is equal to 0. Because nobody likes working with a negative coefficient of x squared, maybe let's divide by negative 1. So this will become 2x squared minus 4x plus 3 minus p equals 0. Okay, right. So the question now says, when will they have 2 unequal roots? Okay, so for them to have 2 unequal roots, the discriminant, 2 unequal roots, the discriminant must be greater than 0. Okay, this is to have 2 unequal roots. Okay, 2 unequal roots, the discriminant must be greater than 0. Remember, your discriminant is b squared minus 4ac. Okay, so what is it? So b is negative 4, as you can see. A is positive 2. C is 3 minus p. And this is greater than 0. Right? So negative 4 all square is 16. Negative 4 times 2 is 8, negative 8 rather, negative 8 times positive 3 is negative 24. Negative 4 times 2 once again is negative 8. Negative 8 times negative p will be positive 8p, and these are greater than 0. Moving on. This is negative 8. 16 minus 24 is negative 8 plus 8p. I don't like writing this step, but it's okay. We'll proceed. 8p is greater than positive 8. Dividing by 8 throughout, p is greater than 1. Okay? We are good, right? Perfect. So, 1.5.2, for which values of p will this guy here have roots that are both positive? To have roots that are both positive, let's understand this. From question 1.5.1, we got A being positive, B being negative. Yeah, B being negative. Oh boy, what's happening? So B being negative. Therefore, to have both roots being positive, C must be what? C must be greater than 0. Okay, C must be greater than 0. Okay, I will show you why this is the case. Guys, if you have, for example, x squared, okay, if you have, for example, x squared minus 3x, maybe let me move it a bit, oh no, it's fine. Okay, x squared minus 3x and say plus 2 equals 0. Agree with me that when you solve for x, you'll get x minus 2, x minus 1 equals 0. And you will see x equals 2 or x equals 1. As you can see, both roots are positive, right? Both roots are positive. We good? Hence, I'm saying the value of c must be negative. So, once again, from 1.5.1, we found that c is 3 minus p. All right? So, let's go. So, c must be greater than 0. And then what is c? It is 3 minus p, isn't it? This must be greater than 0. So, p or negative p is less than negative 3. So, p is greater than, right? Is that so? Oh boy, look at what I'm doing. My mistake here. I'm sorry. I've changed direction already. So P, because we're dividing by negative, it'll change direction. P will be less than positive 3. But hold on. This is saying to us it must be working for all values of P that are less than 3, right? But when this is really happening, it will not really be true. Now, let's try when the roots are equal, right? When the roots are equal, what's going to happen? Right? When the roots are equal, what's going to happen? Let me show you. When the roots are equal, I'm going to go back to the 1.5.1. When the roots are equal, P will be equal to 1. Do you see this? When the roots are equal, remember, we change the inequality to we change the inequality to equality. So you can see when the roots are equal, P equals 1. So to answer this question, I will then say when the roots are equal, P equals 1. Therefore, to answer this question, to have two positive roots, p must be greater than, p must be greater than 1, but less than 3. This is our answer. Remember what I told you guys. I will show you how to get your answers and I will explain where necessary. Right, perfect. 1.6, our last question. 1.6, show that this equation, p squared, open bracket, p squared plus 1 close, multiplied by x squared equals negative 2pq x minus q squared, has no real roots for p and q when q is an element of real numbers and q is not equal to 0. So here we must determine the value of the discriminant. Then we say, open bracket, p squared plus 1 close, x squared plus 2pqx plus q squared equals 0. Equals 0. Our discriminant is b squared minus 4ac. Now you can see here, a is p squared plus 1, b is 2pq, and c is positive q squared. Now let's proceed. What is b? We said open bracket 2pq close square. What is a? Open bracket p squared plus 1 close. And what is c? Positive q squared. Right? Positive q squared. Happy? So we are good. Let's see. 2pq all squared will be 2 squared is 4, then it's 4p squared q squared. Negative 4 times p squared is negative 4p squared times q squared. It's going to be minus or negative 4p squared q squared. Oh boy. Right? And then negative 4 times 1 is negative 4. Negative 4 times q squared will be negative 4q squared. Now collecting like terms, these are the same, so we are left with negative 4q squared, right? As you can see, if we can think of any q value except 0, we will get our discriminant being negative. This is when it's real. But when q is 0, we will get our discriminant being 0. And this will not be the case. Therefore, we conclude and say the roots, the roots are non-real for p and q, all right, when q is an element of real numbers and q is not equal to 0. Remember, I said any value of q you can think of except 0 will give you a negative. Will make negative 4q squared to be negative. But if you say q is 0, this will be 0. And when discriminant is 0, your nature of roots are not real. So this is it, guys. Bye-bye.